A very warm welcome to all the students. Till yesterday's lecture, we have seen what are non-deterministic push-down automatas. We have also seen some examples, some problems. Today, we are going to see an important topic called as computation tree for non-deterministic PDA. You may recall that when we were discussing deterministic PDA, DPDA, that time whenever it was asked for us to validate a string, to trace a string, okay, we were using a representation, and that representation was called as instantaneous description. Okay, this instantaneous description had three parts. One, the current state. Second, the input symbol which is not yet read, which is yet to be read. And third, the current content of the stack from top to bottom, right? And then based on the different transitions in the PDA, we were able to trace the given input string, and we could design instantaneous description. Okay, now since NPDAs, they have non-deterministic nature, okay, at any state there are more than one possible transitions, okay, so that's non-deterministic nature. So the instantaneous description which we had seen in case of DPDA, okay, in NPDA it takes a form of computation tree. So it will be viewed as a tree. Whenever we talk about tree will have different branches. Each branch is nothing but possibility, right? So from a particular node, okay, on reading the same input, if it goes to more than one different states, okay, then those many branches would be there in the tree. Okay, now all the branches won't be fruitful, right? We have seen how to traverse a tree. There are different ways: depth first search, breadth first search, and so on, right? So in this, in depth first search fashion or in breadth first search fashion, okay, when a given input string is given, that string will be traced, and not all paths but only one particular path, one or more particular paths may be fruitful. They may take you from the initial state to the final state. So those paths will be considered for the solution. Okay, to understand it better, let us take an example. Now here I have just randomly taken one NPDA. This NPDA may not make any sense. I have just drawn it roughly so that I can show you. Now why this is NPDA? As you can see, there are different states A, B, C, D, E and F. From state A, on reading 1, okay, as input, irrespective of what is there in the stack, it takes you to state B. From the same state A, on reading 1, irrespective of what is there in the stack, it takes you to D. So from the same state A, on reading the same input 1, it is taking you to more than one states. Further, when you consider state B, from state B on reading 0, okay, it takes you to state C. From the same state B on reading 0, it also takes you to D. Okay, so as I have already told you, non-deterministic nature, if it is present in one or more nodes of a PDA, then that PDA will be non-deterministic PDA, right? So now you are asked to validate a string, okay, and you have to trace this string. Validate means you will have to trace this string over this PDA and find out whether this string is accepted or rejected. That's the meaning of validate. So let us start. Okay, so as I told you, in computation tree also, every node that you can see here is the same as instantaneous description. We already have seen instantaneous description was having three parts, so also computation tree, each node will have three parts. First part will be the current state, then the unread input, and Z0 is the current stack content. I have made this input as green just to show you that in this state A, currently it is reading 1, okay, and others are all unread. Okay, we shall see as we proceed. So initially, okay, we are going to trace this string over this PDA. The tree that you can see here, this is called as computation tree. Okay, all the paths are not fruitful. Your aim was to reach F. As you can see, from A, if you take this particular branch here, you are going to reach F node. So this is one particular branch which is fruitful. But if you see another branch, let's say from A to B, B to this B, B to B, then B to D, you get stuck here, dead end. Okay, a leaf node which is not the goal node, which is not the final node, the tree gets stuck. Similarly here also the tree gets stuck. Okay, so let us see now how PDA will operate, how PDA will perform operations to validate this string. Now initially the input that is given is 111000. So unread input here is 111000. Current state is A and currently the stack is empty, right? Now from state A, when 1 is read, what happens? So if you see here, from A, when 1 is read, it does two operations. One, it goes to B, second, it goes to D. So from A, on reading 1, first it goes to state B. So let's say I consider this transition. So from A, it goes to state B. After reading this one, what is the unread element left? Unread string that is left, it is 2 1s and 3 zeros. So 2 1s and 3 zeros I have written here. Okay, and what operation is performed for this transition? This one that is read when the stack is empty. Okay, from state A, when 1 is read and the stack is empty, that 1 is pushed onto the stack. So in state A, when 1 is read as input, stack is empty. Okay, what we do? That 1 is pushed onto the stack. That's why it is 1 Z0, and by doing that we move to state B. So that's why from this we have another state that is obtained. So from A, on reading 1 and when the stack is empty, we go to state B, and since this one got pushed into the stack which was earlier empty, now the stack would be having elements 1 Z0. Okay, now from A there is other possibility also. From A, on reading 1 and when the stack is empty, that time it does another operation also. This time again it is pushing 1 into the stack but moving to another state called as D. So you see, from state A, on reading 1 and when the stack is empty, it goes to state D also. It goes to state D also, and what operations perform on the stack? One is pushed onto the stack. So earlier the stack was empty, now stack contains 1 into it, right? Now since this 1 is already read, what is the unread string that is left? For this also it is 11000, 11000, right? So from this state there are two possibilities. Now let's consider this now. Now you are, let's say you are in state B, you are in B. Now when 1 is read as input, the next one, okay, and stack already contains 1 on top of it. So in B, when 1 is read as input symbol and stack already contains 1, what we do? This one we push also, onto the stack, and you remain in the same state. So from B, you remain in the same state B, and this one we will push onto the stack. So earlier stack was containing 1 Z0, now it will contain 1 Z0. Since this one is already consumed, unread string remaining will be 1000, so it is 1000. Okay, further, if this branch was considered, okay, that means from A, after reading 1 and after pushing it onto the stack, suppose we have moved to state D, then what would have done? Okay, so from D, state D, on reading 1, and if 1 is on top of the stack, then what you do? See, in D, on reading 1, and if 1 is on top of a stack, what we do? We pop that one out. Okay, that means this one and this one is being cancelled. So it simply means this one and this one will be cancelled. So earlier stack was containing 1 Z0, now it will only contain Z0. Now since this is consumed already, the remaining string will be just 1000, 1000. And this operation is performed and it is moving to the same state D. That's why you are moving to D. But when you consider this further, from state D, on reading 1 and when stack is empty, is such transition present on stack D? Just see in the state D. Now in state D, the possible transitions are 1 here, D to F. Second transition possible is from D to E. Now both these transitions are made on reading null and reading 0, whereas the transition which we are seeing here is D on reading 1. So I cannot go for these two. Now let's see whether this transition is possible. From state D on reading 1, yes, from state D on reading 1. But the stack content at that moment should be 1. What is the stack content here? It is Z0. So is this transition applicable for this state? No. That means from state D on reading 1 and when stack is empty, that transition is not defined over D. So as a result, you are not going to the final state. There is no way, because none of these three transitions are applicable for the moment of this, for the progress of this. As a result, you will remain in D forever, and that's why I have written it stuck. Okay. So as we know, when we go with breadth first search, okay, BFS, what we do, we start from a current node, then we go for the immediate neighbors, immediate child nodes, okay, in the breadth wise. Okay, so we explore this one, we explore this one, then we explore, suppose when we explore this one, we get this one, right? When we explore this one, we get this one, and currently we have reached here and here. But when this was explored further, the thing got stuck. That means you cannot proceed. So what we do, we backtrack from this state to this state. Since there are no more branches, we again backtrack from this state to this state. Okay, then we have already executed this part, we have already executed this part. So that means your answer may be present in this particular subtree, and it is not present in this subtree. So this traversal was unfruitful. So as a result, the PDA has now come to the previous branch only here. Fine. Now, so you are currently over here. Now you are in state B on reading 1 as input, and when 1 is on top of the stack, what happens in state B? When 1 is read as input and 1 is on top of a stack, what we do? We push 1 onto the stack and we remain in B, in the same state B. That means this one we are going to push it onto the stack. So earlier stack contained 2 1s, now it will contain 3 1s. Unread input will be 0 0 0, and by doing this transition we remain in the same state B. Right? You remain in the same state B. Further, from this state B on reading 0, what happens? So from B on reading 0, there are two transitions that are made. From B you go to C, and from B you go to D. So from here, okay, from state B on reading 0, and when the stack contains, top contains 1, okay, one option is this. That means first I will consider this. So when you are in state B, when 0 is read as input and topmost element of the stack is 1, what you do? You simply cancel these two out, okay, and you go to C. So the same thing you are going to observe. So from B you are going to move to state C. After considering this 0, what will remain to be read is 0 0. So you will just have 2 0 here, and I just told you that the transition is made by cancelling this 0 with the topmost one. So after cancelling 0 and 1, the stack content will be 2 1s and Z0. Earlier it was 3 1s and Z0, now it is 2 1s and Z0. And after cancelling this 0, what remains is 2 unread zeros. You go to state C. What is the second possibility? That also you need to explore. So from B on reading 0, and when 1 is on top of a stack, you also go to D. But in this case, what you do is you ignore 0. You perform no operation on the stack. That's why 1 was on top of the stack, 1 still remains on top of the stack. Okay, so this is that. So from B, you move to D. Now since this 0 is already read, how many zeros should be left unread? 2 zeros. So I write 2 zeros. And since we are ignoring this 0, earlier stack contains 3 1s and Z0, and now also stack will contain 3 1s and Z0. Right? But now, so from B we have explored this path and we have explored this path. But when we explore this path further, from D on reading 0, there is a transition. But at that time the stack should be empty. Only then you will be able to reach E. But what happens here? From state D on reading 0, is the stack empty? No, there is 1 on top of the stack. So D on reading 0 as input, and when topmost element of the stack is 1, there is no transition defined for that. For 0, 1, there is no transition defined. So you will always remain in D forever if you go through this branch. That's why here also it gets stuck. So since this branch is not fruitful, it backtracks here and it tries to continue with this path. Okay. Now, so we are here now. Okay. So from state C on reading 0, and when 1 is on top of stack, what happens? So stack from the state C on reading 0, and when 1 is on top of a stack, 0 and 1 get cancelled. Okay, that means 1 is popped out from the stack and you remain in C0. in the same state C. So from C you remain in C. After reading this 0, what remains is 0 only, single 0. And since you are cancelling out this 0 with this one, earlier stack contained 2 ones and z0, now stack will contain 1 z0. Agreed? And you are in the same state. Now again in the similar manner, from state C, in state C, on reading 0 and when 1 is on top of a stack, again you are going to cancel 0 and 1 and you are going to remain in the same state C. So as a result you will be remaining in the same state C, and this 0 and this 1 will get cancelled. So what is remaining to be read is null, and the stack is now empty, z0 is there. Now finally, when you are in state C, when nothing is remaining to be read, stack is also empty, you perform no change operation and then you go to the final state. So from C, when nothing is remaining to be read, stack is also empty, you go to state F and it is no change operation performed. So that means this is a final state. So now if you happen to see, there were so many paths. Which path was fruitful? Okay, this path was fruitful. So from A to B, then this node to this node, then this, okay, then this, and then this. This was the path that was fruitful, and all other paths, although the possibilities were there, all other paths after traversing, PDS finds out that the path don't take you to the final state, so those paths are ignored. So after seeing each and every possibility this way, PDA finally says that the given string is accepted, because there is at least one path that takes you from the initial state to the final state on reading the entire input string. Okay, so this is something called as computation tree for push down automata. So please don't get confused. Although from a particular state there may be thousands of different possibilities, there may be thousands of different branches, what PDA will do? PDA will consider each branch and it will try to traverse and see whether it goes to the final state. And suppose at any point if it gets stuck, then PDA will do the backtracking and see whether any other path is fruitful. And this way, out of so many paths, at least one path it will find out if it is taking it to the final state. Then if such path is possible, then PDA will finally say that the given string is accepted. And if all paths, all possible paths, all are fruitless, okay, unfruitful, all get stuck, they don't take you to the final state, then the PDA will say that the given string is rejected. Please note, the Npda we will be designing, it makes 3 assumptions. First, the symbol that is scanned, it belongs to the first half of the input string, that is before the middle marker character. Okay. Second, the symbol that is scanned is the middle marker character itself. And third, the symbol that is scanned belongs to the second half of the input string, that is part after middle marker character. What it simply means, given say some string is given to you, say AB something something. When any input string, the current input string is read by the Npda, okay, it will make 3 assumptions. First, it will assume that whatever it is currently scanning, it is a symbol from the first half of the input string, and then it will compute the possibilities. Second, it will assume that the currently scanned input symbol B, it is the middle marker character itself, and then compute the possibilities. And third assumption, it will assume that the current input symbol that is scanned, that is B, is from the second half of the input string, and accordingly do the computations. So basically, as we have already seen, computation tree, if you can visualize, it will have 3 branches. Okay, then again it will have more 3 branches and so on. So at least one path will work. Okay, so let's proceed and see. So the Npda will make 3 assumptions. At every point it will do this. It will make 3 assumptions. First, it will assume that whatever is currently read is belonging to the first half of the input string. Second, it will assume that the whatever is scanned currently is a middle marker character itself. And third, whatever that is scanned currently belongs to the second half of the input string. So they are the 3 assumptions. Now, if it assumes the first thing, that is, if this symbol is assumed to be from the first half of the input string, then what action it will take? Okay, our PDA will react in different ways for each assumption. So first, if it assumes that the input symbol belongs to the first half of the input string, okay, then what it will do? It will push that symbol onto the stack. Okay, so it will simply push the symbol onto the stack if the symbol belongs to the first half of the inputs. If it assumes that the current input symbol that is read is from the first half of the input string, if it assumes that, what it will do, it will push that symbol onto the stack. Second, when it assumes that the current input symbol happens to be the middle marker character, then what it will do, it will ignore that symbol, and ignore means perform no operation. And third, if it assumes, when it assumes that the currently scanned symbol belongs to the second half of the input string, that is after the middle marker character, then what it will do, it will check with the topmost element of the stack. See, because if something is present in the later half, after the middle marker character, those things have to be compared with the stack elements, right? So it will check the topmost element of the stack, and if this symbol which is currently read, it belongs to the second half, okay, then it will just check with the topmost element of the stack, and if there is a match, it is going to cancel out the stack element with the currently read element. Right? So these are the three things, three assumptions, and these are the three actions that it will take. Okay, so now before we design PDA, let's see, this PDA that we are designing, it will have the following three states. Now Q0, okay, it will be the initial state. So the machine remains in Q0. Okay, the machine remains in the state Q0. Okay, and it pushes the symbol onto the stack. So when it is in Q0 state, the PDA will assume that whatever symbols that are being read, may it be the first symbol, second symbol, third symbol, or the last symbol of the string. Okay, in Q0 state, PDA will assume that whatever symbol that is being read by the PDA, they are belonging to the first half of the input string. Okay, and since it assumes that those symbols are belonging to the first half of the input string, what action it will take? It will simply push whatever is read, it will simply push those symbols onto the stack. So in Q0, the PDA assumes that whatever it is reading, whichever symbols that are being read currently, they are from the first half of the input string. Okay, so the action, corresponding action that it will always take is, it is going to push all those elements onto the stack one by one. Now then also see, whenever it is in state Q1, whenever PDA is in state Q1, what it will do, it will assume that the current input symbol that is being read belongs to the second half of the input. And since it is second half, cancellation has to be done, right? Popping and cancellation. So, okay. So, here what will happen in this state? Each symbol that is currently scanned or currently read will be compared with the topmost element of the stack. And the cancellation takes place by popping the topmost element out of the stack. And cancellation will happen if there is a match. So, Q0 is a state wherein the assumption is whatever is read will be from the first half of the input string, and those symbols will be pushed onto the stack. Whenever it is in Q1 state, it will assume that the element belongs to the second half of the input string. So whatever is reading, it is being read, will be compared with the topmost element of the stack, and the cancellation will happen. Okay, but so we have seen in Q1 state it assumes that it is in the first half. In Q2 state, in Q0 state, it assumes that the currently input symbol that is read belongs to the first half. In Q1, it assumes that it belongs to the second half. Then the transition that connects Q0 and Q1, on that transition the assumption will be made that the current input symbol is a middle marker symbol. And since it's a middle marker symbol, that whatever is the symbol, maybe the first, second, third, fourth, whichever is the symbol, it will be simply ignored. Okay, so no operation will be performed on the stack. Only what will be done? Only the transition from Q0 to Q1 will be done. Okay, so let us now design the PDA, right? So as I have told you, PDA will have two states. Q0 is the initial state. Q0 is the initial state, and in Q0 state the machine will assume that whatever is being read belongs to the first half of the input string. Now what kind of strings can we get? For example, we can get a string something like this, A and so on, which is a palindrome string, of course. You may get a string something like A, B, B, A, which is also a palindrome, Okay, or you may get a string of type say BAAB, which is also a palindrome, or BBBB, which is also a palindrome. They are all even length palindromes. In case of odd length palindromes, okay, you may receive a string, for example 2 A's, then this is that middle marker character A followed with 2 more A's. Okay, now for this it may consider say AB, A, B, A, where this A happens to be the middle marker character. Okay, then the string can be B, A, say B, A, B. This is here also this is a middle marker character. Again see, middle marker character, it can be A as well as B, anything. I have just taken it as A, but other string wherever there B is a middle marker symbol, that will be also a correct palindrome. And the last possibility, say BB and say ABB or something like that, or BBBBB. All these will be odd length palindromes. Okay, so these are the possible strings which this PDA should accept, all even as well as odd length palindrome. So first what we are doing is we are assuming that whatever is being read is from the first half of the input. Okay, so let's say A is read, or let's say this A is read. Now since it is the first A that is being read, okay, since this is the first A that is being read, what will happen? Your stack will be empty, right? So when you are in Q0, okay, when first A is read, that time stack will be empty. Since it is assuming that it is from the first half of the input string, that A has to be pushed onto the stack. So the stack now will contain AZ0. Correct? Similarly, for the strings like this, okay, a string can also start with B, no? So if the first element, B is the first element that is being read, then what will happen? So that time also when first B is read, the stack will be empty. That time also that B will be pushed onto the stack. So this is what will happen for the first element of the string which is read in our first assumption that is made in Q0 state, that we are assuming that the currently input symbol that is being read is from the first half of the input. Correct? Now assume that either A or B, one element is already present in the stack, and what we are scanning now is not the very first element but maybe the second, third, fourth, for any other element. So there are 4 possibilities now. It can so happen that the second element that is being scanned is A and the stack may contain B already. Correct? Or let's say the current input symbol is A and stack may contain A previously that is inserted. Or maybe the current input symbol that is scanned might be B and the stack may contain A, or B is the current input symbol and stack may contain B. So these are all 4 possibilities when we consider the second input symbol that is being read, or third, fourth, fifth, sixth element input symbol that is being read. Whether the topmost element is B or A, that is defined by what was read previously before this current input symbol, right? So in all these cases, as we know, since in Q0 the PDA makes an assumption that it is from the first half of the input string, whatever is read is the first half of the input string, it has to strictly push whatever is read onto the stack. So all these will be pushed onto the stack. So what will be pushed here? AB will be pushed onto the stack. Here AA will be pushed onto the stack. BA will be pushed onto the stack. BB. So all possibilities we have considered here. Okay. Now Q1, as we have already seen, Q1 is a state where the current input symbol that is being read is assumed to be belonging to the second half of the input string. And what we do if something is belonging to the second half of the input string? If something belongs to the second half of the input string, we check that symbol with the topmost element of the stack, and if they are same, then we pop, right? So now what are the input symbols that are possible in these strings? Either the symbol can be A or the symbol can be B, nothing else, right? So when you assume that the currently input symbol is from the second half of the string in Q1, the current input symbol read might be either A or it might be B. Now in both cases we check the topmost element of the stack. If here there is A on top of a stack or there is B on top of a stack, so if the current input symbol is A and topmost element of the stack is also A, or current input symbol is B and topmost element of the stack is also B. That means there is a match. So these this kind of matches have to be popped out, cancelled out. So cancelling means popping out and pushing null. So this is what will happen in Q1 state. So in Q0 state, as I told you, simple pushing happens, assuming that each input symbol that is being read is from the first half of the input. In Q1 state, popping happens, matching and popping happens, assuming that whatever is being read, that is either A or B, whatever that is being read is belonging to the second half of the input string, that is after middle marker character. What kind of strings can we get? For example, we can get a string something like this, A and so on, which is a palindrome string, of course. You may get a string something like A, B, B, A, which is also a palindrome. Okay, or you may get a string of type say B, A, B, which is also a palindrome, or B, 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 which is also a palindrome. They are all even length palindromes. In case of odd length palindromes, okay, you may receive a string, for example, 2 A's, then this is that middle marker character A followed with 2 more A's. Okay, now for this it may consider say A, B, A, where this A happens to be the middle marker character. Okay, then the string can be B, A, say B, A, B. This is here also, this is a middle marker character. Again, see, middle marker character, it can be A as well as B, anything. I have just taken it as A, but other string wherever there B is a middle marker symbol, that will be also a correct palindrome. And the last possibility, say BB and say ABB or something like that, or BBBBB. All these will be odd length palindromes. Okay, so these are the possible strings which this PDA should accept, all even as well as odd length palindrome. So first, what we are doing is we are assuming that whatever is being read is from the first half of the input. Okay, so let's say A is read, or let's say this A is read. Now since it is the first A that is being read, okay, since this is the first A that is being read, what will happen? Your stack will be empty, right? So when you are in Q0, okay, when first A is read, that time stack will be empty. Since it is assuming that it is from the first half of the input string, that A has to be pushed onto the stack. So the stack now will contain AZ0. Correct? Similarly, for the strings like this, okay, a string can also start with B, no? So if the first element, B is the first element that is being read, then what will happen? So that time also, when first B is read, the stack will be empty. That time also that B will be pushed onto the stack. So this is what will happen for the first element of the string which is read in our first assumption that is made in Q0 state, that we are assuming that the currently input symbol that is being read is from the first half of the input. Correct? Now assume that either A or B, one element is already present in the stack, and what we are scanning now is not the very first element but maybe the second, third, fourth, for any other element. So there are 4 possibilities now. It can so happen that the second element that is being scanned is A and the stack may contain B already. Correct? Or let's say the current input symbol is A and stack may contain A previously that is inserted. Or maybe the current input symbol that is scanned might be B and the stack may contain A, or B is the current input symbol and stack may contain B. So these are all 4 possibilities when we consider the second input symbol that is being read, or third, fourth, fifth, sixth element input symbol that is being read. Whether the topmost element is B or A, that is defined by what was read previously before this current input symbol, right? So in all these cases, as we know, since in Q0 the PDA makes an assumption that it is from the first half of the input string, whatever is read is the first half of the input string, it has to strictly push whatever is read onto the stack. So all these will be pushed onto the stack. So what will be pushed here? AB will be pushed onto the stack. Here AA will be pushed onto the stack. BA will be pushed onto the stack. BB. So all possibilities we have considered here. Okay. Now Q1, as we have already seen, Q1 is a state where the current input symbol that is being read is assumed to be belonging to the second half of the input string. And what we do if something is belonging to the second half of the input string? If something belongs to the second half of the input string, we check that symbol with the topmost element of the stack, and if they are same, then we pop, right? So now what are the input symbols that are possible in these strings? Either the symbol can be A or the symbol can be B, nothing else, right? So when you assume that the currently input symbol is from the second half of the string in Q1, the current input symbol read might be either A or it might be B. Now in both cases we check the topmost element of the stack. If here there is A on top of a stack or there is B on top of a stack, so if the current input symbol is A and topmost element of the stack is also A, or current input symbol is B and topmost element of the stack is also B, that means there is a match. So these this kind of matches have to be popped out, cancelled out. So cancelling means popping out and pushing null. So this is what will happen in Q1 state. So in Q0 state, as I told you, simple pushing happens, assuming that each input symbol that is being read is from the first half of the input. In Q1 state, popping happens, matching and popping happens, assuming that whatever is being read, that is either A or B, whatever that is being read is belonging to the second half of the input string, that is after middle marker character. Now there is a transition that connects Q0 to Q1, and in here the PDA assumes that it will do the transition from Q0 to Q1 if the input that is read is assumed as a middle marker character. So that's what we said, the current input symbol is assumed to be middle marker symbol. What we do in that case, no operations performed on the stack, but only the transition is made from Q0 to Q1. So only the transition will be made. So whatever input that I have read here, the same inputs will appear here, but only thing is that here the operation on the stack was push, here the operation on the stack will be no change operation. So from initial state Q0, it can happen that A that is being read could be the very first element, but since we have assumed that it is a middle marker character, what we do, we don't push that first A onto the stack, rather stack remains unchanged. Similarly, the B that is read, if it is assumed that it is the first input symbol that is scanned, here in Q0 state we pushed it into the stack assuming that it's from the first half. Now here we are assuming that it's a middle marker character, so you don't have to push, you have to perform no change operation on the stack. So Z0 which was on top of the stack, Z0 still remains on top of the stack. Then assuming that A is from the is not the first input symbol read, but maybe the second, third, fourth input symbol that is read. So in that case you don't push A's, rather A will be on top of the stack as it is. The A that was on top of stack, A still remains on top of the stack. Similarly, suppose if it is A comma B, then B will still remain on top of the stack. Suppose it is say B comma A, then A still remains on top of the stack. Suppose it is B comma B, then B still remains on top of the stack. So these are all the possibilities, but there are some more possibilities also. So whenever we deal with palindromes, there are also for example, when you talk about even length palindrome, null is also a valid even length palindrome. When you talk about odd length palindrome, single A or single B is also a valid palindrome, correct? So now please note, if null is given as input string, and the stack is empty, that means null is the input string that is given, so you will perform no change operation, and after performing the no change operation, what you will do, you will come to Q1 state. Now see, this comparison thing is an optional thing. Because it's a self loop. So if null is the input string given to you, then from Q0 state on reading null, and when stack is empty, you will perform no change operation, and from Q0 you will come to Q1 state. And then in Q1 state, when there is nothing remaining to be read as input, and that time stack is also empty. What you will do? You will perform no change operation and you will go to the final state, that is Q2. Okay, that's a final state Q2. So basically what we are doing, for any input string that is given, okay, first in Q0 state we will assume that it is from the first half, okay, then we will assume that it is the middle marker character, and then we will assume that it is from the second half. But ultimately at the end, when there is nothing remaining to be read, stack is also empty, okay, you perform no operation and you go to the final state. So this is how null will be accepted. That's why I have written null here and null is not written here. Similarly, now when you consider strings like single A, single B, they are odd length palindromes. Those also should be accepted. Okay. Now in this case, what will happen? Okay. See, if suppose single A is given as input string is single A, okay, what will happen? From Q0 state, okay, on reading A, from Q0 state on reading A, okay, you can push that A onto the stack and you can remain in Q0. Okay, the first option is, I'll just write it as a computation table so that you can easily understand it. Say initially you are in Q0 state. Suppose A is the input that is given and initially the stack is empty. Now from Q0 state on reading A, what are the options? Okay, from Q0 state on reading A, either you can go to Q1 or you can remain in Q0, right? So let's write this first. So from Q0 state on reading A, you remain in the same state. Now after A is consumed, there is nothing remaining to be read and that A will be pushed onto the stack. Okay, so I have considered this transition. Now from Q0 state on reading A, there is another transition. Okay, and there the A can be ignored. Okay, so when you are in Q0 state on reading A, you can go to Q1. After ignoring A, what will be remaining to be read will be null, and since A is ignored, the stack initially contains Z0, now also it will contain Z0. Okay, so this is possibility 1 of pushing the elements into the stack. This is possibility 2 of no operation. Now the third possibility, that is considering that the current input symbol that is read, that is A, happens to be from the second half of the input string. Now that possibility will not arise in Q0 state because that we are considering in Q1. So you have to go to Q1 and only then the third possibility will come. So as a result, okay, the transition that we do here will be kind of null transition. Okay, and that null transition will say that from state Q0, okay, on reading, without reading anything, okay, it will simply go to Q1. That's a null transition. So the null transition that I am going to write is Q1 because we are making transition without reading anything. Stack is also empty. Fine. So the third possibility, that is A as a middle marker symbol. See, first you are considering that A happens to be from the first half of the input string. Then second, we are assuming that A happens to be the middle marker character. Now the third possibility, that A belongs to the second half of the input string, will not arise in this case of mine because we are in Q0, and in Q0 we are considering only two possibilities. One is assuming that it is from the first half of the input string, and second, assuming that it is a middle marker character. Whereas assuming that the input symbol belongs to the second half is not considered here. It is considered in Q1 state. So we are simply making a null transition to Q1 state. Okay. Now, so I was just telling you what will happen when a single A is given as input. This is also a valid palindrome, odd length palindrome. So from Q0 on reading A, there are two possibilities, 1 and 2, and third is a null transition. So we will ignore this null transition. Okay. Now, further, when you are in Q0 state, let's consider this. When you are in Q0 state and when nothing is read as input, okay, so in Q0 state, just see these transitions. Null red is input. Is there any such transition? There is no such transition. As a result, you will get stuck over here. Okay, you will get stuck over here. So you will, if you consider this branch, okay, you will get stuck. Now second branch that we have considered, that is from Q0 on reading A, okay, from Q0 on reading A, and when the stack is empty, you are assuming that A which is read is a middle marker character, you are ignoring A and you are performing no change operation and you are simply moving to Q1 state. That is this one, right? You have already moved to Q1 state. Now in Q1 state, these transitions are optional. This is a self loop. So in Q1 state, please note, in Q1 state, when nothing is remaining to be read, stack is empty. What happens? So in Q1 state, when nothing is remaining to be read, stack is also empty. What do? You perform no change operation and you will go to Q2. So here, you will simply go to state Q2. Since it is no change operation, stack also will remain unaltered. So as a result, for the single element like single A, okay, valid odd length palindrome, minimum possible, okay, for such this kind of path will be fruitful, whereas this will be stuck and this we are not considering, this also will be stuck. Okay, so this PDA that we have drawn, it considers null palindromes also, okay, palindrome with a single length A or B also, right, and as well as other palindromes of even length and odd length. So this is a PDA that we have drawn. This is a PDA, non-deterministic PDA accepting all palindromes, even length as well as odd length, along with minimum possible even length, minimum possible odd length palindromes too. So we are now going to see one example. Assume that the string that is given to us for tracing is B, A, B. This is a string that is given for us for tracing. So initially, so this is a computation tree. Okay. Now here we are using some notation. You see here this is hash. Now hash means push operation was made to reach the current ID, instantaneous description. So wherever hash occurs, it means push operation was made. Now here there is dollar. So wherever dollar occurs, it means input symbol was ignored, assuming that it's a middle marker character. Then there is also at the rate. Now you see in the first stage here there is no at the rate, but if you go down somewhere, here there is at the rate. So at the rate means we have performed pop operation, and star that I have written here, star is nothing but a null transition was made to reach the current state, and I have just told you what's a null transition. Okay, so we will trace a few things. First, let's say in Q0 state, the first input symbol scanned is B, single B. So from Q0, when single B is scanned, stack is empty. What can you do? You can do different things. One, hash. That means we are talking about push operation. These are the push operations. So when B is read, stack is empty. B is pushed onto the stack. Okay, and you remain in Q0. So the same thing is done. B is pushed onto the stack. So see, the stack contains now B Z0, and you remain in the same state Q0. Since it's a push operation, I have written star. This is one possibility. Second possibility, assuming that the B that is read currently is a middle marker character. In that case, B will be ignored and stack will remain as it is, and you will move from Q0 to Q1. So that was the second option. Okay, dollar, that is no change. So you have already moved to Q1. This is the remaining string, and stack is unaltered. Right? Then from here the other possibilities and so on. So you can simply trace this. Okay, you know how to trace now. Just trace this, and you see when you reach here, there are no transition. That means you are getting stuck. Here also there is no transition. That means you are getting stuck. From this branch here, there is no transition. You are getting stuck. Finally, you see, okay, there is one path that gives you the answer. Okay, that is from here. Then you move here. Okay, then you take up this path. Then you can take up this path, then this, and you reach the accepting state, the final accepting state. So in Npda, finally I conclude by saying that in Npda, out of all the different possible paths, if at least one path takes you to the goal state, to the final accepting configuration, if at least one path takes you there, okay, then the PDA will say that the given string is accepted. What PDA will do? PDA will use breadth first search procedure. If it is getting stuck somewhere here, it will backtrack and see whether other path is possible, other branch is possible, and so on. And by doing this breadth first search traversal, if PDA finds at least one path that takes you from the initial state to the final state, final accepting configuration, okay, then Npda will say that it is accepting the given string, otherwise it will be rejecting the given string. So you can please trace this particular computation tree diagram. Okay, thank you.